Guys, hope you all doing extremely well. Let's continue our Blend 75 series, and we have solved three problems from dynamic programming. Let's move on to the next problem, which is longest common subsequence. Okay, so it is saying that we will be given two strings, text1 and text2, and we have to return the length of their longest common subsequence. If there is no common subsequence, then we will return 0. Let's understand what it is saying. Yes. So here we have to find out the length of longest common subsequence. And we know that if we have a string like this, A, B, E, F, G, I, then the possible subsequences we can make out of this string will be like this. AE will be a subsequence, AEF can be another subsequence, AGI can be a subsequence, in this way in which we can skip characters from this string and while maintaining the order, then we can form multiple subsequences. What we have to do here, we will be given two strings, text1 and text2, like this, text1 and text2, and this can be something like this, EGI. And if we create a subsequence from both of the strings, they should be same and their length should be longest. So if we talk about common subsequence, E itself alone is a subsequence which is common in both, and EG is also another subsequence. E is a separate subsequence. E and G can be a subsequence. EG, we can get EG from here also, from subsequence as EG from here also. So it is common between both the given strings, and EGI can also be considered as a subsequence which is subsequence from text1, and it is also a subsequence from text2, and that too it is common from both text1 and text2. And one more thing, if you notice, it is the longest one. So if we have two input strings like this, then we will return 3 here, because here the length of the longest common subsequence is 3. Okay, now we have understood the problem statement. Now let's move on to the approach, how we are going to approach it. Here in these cases, when we have to find and maximize the length of common subsequence like this, here we have to try each and every combination. Here we have to try that if this character is matching with the other character in the other string, if it is matching, then can we form a subsequence, can a subsequence be formed starting from this character. So we have to check each and every possible combination, and when this case comes, recursion comes in our mind. So we are going to use recursion here with a top down approach, which is also called recursive approach. What we are going to do here, let me take this example 1 from here, given example. Here the string 1 is A B C D E, A B C D E, and another string is ACE. So we have the main problem like this. We have two strings. What I'm going to do, I'm going to place pointers in the starting of both the strings. let's name this pointer which is starting which is placed at the starting character of the first string as I, and let's name this pointer as j, which is placed at the starting of the second string. So what I'm going to do, I'm going to see if they are same or not. Characters at these two indexes are same or not. Here in this case, yes, they are. So I will do 1 plus, and rest of the work I will give to recursion. I have done a small work for myself, and I will pass rest of the work for recursion. Recursion we will see how I have done, and it will do rest of the work and give me the solution for the rest of the work. So how I'm going to give to recursion. So these were my strings a, c, e. I will move on this pointer to the next character, and this j pointer also to the next character. So, and whatever I will give this problem to recursion, and whatever the answer recursion gives me, I will add 1 to that answer and return as the answer of the main problem. Why I have added 1? Because whatever length recursion gives me, I have passed this much only to recursion, excluding 1 character from both the strings. They were equal, so I know the length, the answer, the longest length for the original problem will be 1 plus the answer returned by recursion. This one is added for the character which is same here and which was compared by me. Alright, now let's trace for a few more calls and see how it is working. Now when the characters at index I and j are not matching, then what I am going to do? Then in that case I will make 2 recursive calls. Let me make this arrow a smaller one, like this. I will make 2 recursive calls like this. I have 2 string a, b, c, d, e and a, c, e. Here also a, b, c, d, e and a, c, e. And in this recursive call I will keep I at its original position, and I will move j pointer to the next character. Here I will move I and will keep j at its original position, and whatever answer given by these 2 recursive calls, I will take max of them. I am going to take max, and that I will pass here. So I have tried. If I'm keeping this b in my subsequence, can I find later on any b in the other string? And if I am moving here the ith index, so I am basically checking if the character at jth index is present somewhere ahead of b or not. I am checking this only, and whichever call gives me the maximum answer, longest length, that I will consider as my answer, and I will add 1 to it and return as the answer of the main problem. Now let's trace for few more calls to observe some pattern here. Now again I will check. Before making any recursive call, at each step I am going to check if the characters at ith index and jth index are same or not. Are they same? In this case, no. I is representing b and j is pointing to c. They are not same. So here also I am going to make 2 recursive calls. What will be they? A, B, C, D, E, A, C, E, A, B, C, D, E, A, C, E. In one call, I will keep I at original position and will move j ahead. And here I will move I and will keep j at its original position. All right, now let's let's move further here also in this call. And here the characters are same, so I will not make two calls. I will make only one call and add one by myself. And I will make call, and that will be like this, that it is going to be a single call only, ACE, and I and J will both move one place forward. I will come here and J will come here. All right. And one thing you can notice here is that if you see this subproblem where I is pointing to C and J is pointing to C, here also I is pointing to C and J is also pointing to C. These two subproblems are exactly same. So basically they are overlapping subproblems. When we see overlapping subproblems in case of our recursive solution, then to optimize the solution we use dynamic programming. So here we are going to use dynamic programming and DP array. And how will be our DP array? Is it going to be one dimensional or two dimensional? It is going to be 2D DP table. Why? Because here we are managing two things, ith index and jth index. So it cannot be managed by 1D array. We have to take two-dimensional DP array for storing the answer for each combination of I and j. At the end, when this j will move or this I will move out of bounds of the string, then we'll reach our base case. At that case, we'll simply return 0. And for showing you the base case, let's proceed this further and this call further. Here are the characters pointed by ith and jth index are same or not. They are not same, so I am going to make two calls here, and they will be like this: A B C D E A C E A B C D E A C E. In first call I will move I forward and will keep j at its original position. In second call I will keep I at its original position. I will move j forward. So this is the call where I have reached base case because j has moved out of bounds of the second string. So here I will return 0 because I have second string as empty, so there is nothing to compare. So there cannot be any longest common subsequence, hence I am returning 0 here. I hope you understood how we are going to write this recursive function. Now let's jump onto the code and you will get better understanding. First we will start with the creation of DP array. For that I have to calculate the length of the two strings. So I am calculating length 1 is equals to text1 dot length, and length 2 will be text2 dot length. Now let's create 2D vector of vector int dp, and its size is going to be, I'm keeping length 1 for storing that it will be the number of rows in this 2D vector, and I will use that for saving the indices of string 1. And as I need indices from 0 to n-1, I will get it if I keep length as length of the string. So I am keeping this length 1. Then each row will be a vector in itself, and its size will be length 2, and initially I will fill all the cells with value -1. Now I'm going to make a call for the helper function, which will be the main function calculating the longest common subsequence length. And here I'm going to pass string 1, text 1, text 2, and ith index, jth index, both will start from 0, and then our dp array. Now let's create this helper function. It is going to return an integer, so return type will be int, the name of the function, then string t1. I will keep them as reference, so to reduce the time complexity. String t2, then int I, int j, vector of vector int I reference dp vector. All right. Now the starting I will write base case, and now what will be our base case. If I reaches end of the string means t1 dot length, or j reaches end of the second string, that is t2 dot length. In this case I have reached the base case. I will simply return 0, then I will check dp, and I will check like this: dp of I and j. If it is not equals to -1, that it must be holding some valid answer. I will simply return that. After that, as I have shown you in the explanation, I will first check if the current characters pointed by ith and jth index are same or not. So t1i, is it equals to t2j? If it is so, then what I have to return, and before returning I have to save it in my dp array. I j is equals to 1 plus, I have found out the one character which is same in both the string. I will add that, and I will pass rest of the strings for recursion to solve it for me. So I will again call the function. I'll pass t1, t2, and I plus 1, j plus 1. I will move here both the indices by 1 because I know that they are the characters at these indexes now are same. Then our dp array. In the other condition, when they are not same, then what will we are going to do? We are going to find the maximum of 2 recursive calls. So I am going to save the answer. So I am doing like this, and then maximum of the 2 calls. What will be our 2 calls? It will be like this: t1, t2, I at its original position, and j plus 1 dp. In other, we'll move I and we'll keep j as same as before: t1, t2, I plus 1, j, then dp. This is it. This is the whole code. Let's try to run it and see if it is working. And there is some, yes, I have to return also this answer, this maximum value. And one more problem here, I think. Yes, yes, one more angular bracket. Let me write it again. What is the problem here? len1, then vector int, yes, len2 minus 1, like this. Yes, it is working fine. Let's try to submit it. Yes, it got successfully accepted. Now let's move on to the next approach for this problem, and it is going to be bottom up approach. It is also known as recursive approach. What I'm going to do in this approach, I'm going to create the same 2D DP table like this. Let me take the same example for the explanation. Alright, let's take this same example: A B C D E, A B C D E, and other string as ACE. ACE. Ignore this extra row. Alright, and I will start by filling zeros here. Now each cell here represent one thing, that is, if I am filling this cell, say I am filling this cell, it is going to store the length of the common subsequence of this substring and this substring. At last, for finding longest common subsequence between these two given strings, I have to find out this value. Alright, I will, at the end I am going to return this value, but I will start calculation from here. If the characters are same, if I am at this cell and the character represented by column and character represented by row, if they are same, then what I'm going to do, I'm going to check what is the value diagonally left side in upward direction. It is 0, so I will simply add 1 in it and I will write here. So I am basically telling you how I'm going to fill this TP so that eventually I will get this value and I'm going to return it. Okay, now I will move on and I will try to fill this value. So this cell is basically telling that if I'm taking A from here and here, so the length of common subsequence is 1 here in this case. If they are not matching, the characters are not matching, I have taken A character from here and 2 characters AB from the second string. If they are not matching, then I will take the maximum of 1 and 0, 1 cell above and 1 cell in the left side, which will be 1. And here also they are not matching 1, not matching 1, not matching 1. Now for the C, are they matching? C and A are matching? No, they are not matching. So the maximum of 1 cell above and 1 cell left will be 1. Now here BC matching? No, then also 1. C and C, are they matching? Yes. So I will go here, I will go diagonally upwards in the left direction, and whatever value I will find, I will add 1 here, because I know that this is representing the length of a common subsequence for this much string, AB from here and A from here. Now for C, AC and ABC, I will add 1 to this value, because the next characters are same from both the strings. So from whatever the length of the previous common subsequence, I can add 1 from it, and that will be my current answer. So here my current answer will be 2. Then I will move ahead. Are C and D matching? No, they are not. So maximum 1 or 2, it will remain 2. And again maximum 1 and 2, as E and C are not matching, again it will be 2. Now I'm going to fill this row, the last row. E and A, are they matching? No. So maximum of 0 and 1, 1. B and E are matching? No, they are not matching. Maximum of 1 and 1, 1. E and C, are they matching? No. Maximum 1 and 2, 2. E and D, are they matching? No, they are not matching. Maximum of 2 at 2, it will be 2. Now E and E, are they matching? Yes, they are matching. So I will go diagonally upwards in the left direction, and I am finding this value 2. So I will add 1 from it, and that will be my answer for this cell. It will be 3. So if I am taking whole string from text 1 and whole string from text 2, so this is the longest common subsequence I am getting for it, for the as my final answer for the main problem with which I started. Now you may ask me that for what purpose I have kept this extra row and column and I have filled it with 0. It is telling that for character A, C and E, and when the second string is empty, so longest common subsequence will be 0 0 0. And here also, when this is empty string, and I am taking one character from here, two character from here, so it will all remain 0. Alright, so this will be my answer. I will return it. Now let's code it how I explained. I will code in the similar way. Before coding it, let me talk about the time complexity and space complexity of the previous approach, that recursive approach we have used here. So the time complexity here is going to be big O of n into m, where n represents the length of the first string and m represents the length of the second string. Why? Because we have created 2D table of size n into n, and we are filling each cell by processing by running the recursive function, and we are filling here n into n times. So its time complexity is going to be n into m. And talking about its space complexity, it is also going to be order of n into m, because we have made this DP array, 2D DP array, whose size is n cross m. Now let's code it with the second approach. Here also I'm going to create DP, and if you notice one more thing here, that here the size is, if I am taking this as n is 3 and m is 4. Size is 4 into, sorry, it is 5, but the actual size is 4 into 6, means plus 1 from the first string and also plus 1 from the second string. So the matrix which I am going to create will be n plus 1 into m plus 1. First let's calculate the length. Length 1 will be text1 dot length, text1 dot length. Similarly, length 2 will be text2 dot length. Then our 2D vector dp len1 plus 1 and vector int len2 plus 1. I am initially filling all the cells with value 0. Now let me iterate over this vector so that I can fill it. I'm starting with 1 because I want the 0th column and 0th row to be filled with value 0. So I'm not running it for I is equal to 0 and j is equal to 0. Then I must be less than length 1 and I plus plus. Similarly, j will be 1, j less than length 2, j plus plus. So I will be iterating over rows and j will be iterating over columns. And here I will check if text 1 I, and I will do here -1 because I'm calculating for, if I'm calculating for this cell, then its coordinate in the matrix is 1 by 1, 1 into 1, but the index for the first character from this text 1 will be 0, so I have to subtract -1. You see here I have added 1 extra, so I am subtracting here so that I can get correct indexes for the string. Alright, if it is equals to text 2 j -1, similarly I will do -1 here so that I can get the correct index. For j is equal to 1, I want to get the first character, so j 1 -1 0, I will get the first character from this string. If they are equal, then you know what I'm going to do. I'm going to fill it with dp I, and j will be 1 plus dp I -1 and j -1. That you have seen whenever we find the matching character. Here we had found the matching character e, so we went I -1 means 1 row ahead and 1 column ahead. It will be this cell, and simply whatever value is already placed there, I will add 1 to it. If they are not matching, means else dp I and j will be maximum of one cell in left or one cell in above. For coming to left, it will be j -1, means dp I j -1, and for going one cell up, it will be I -1 and j will remain same, I -1 and then j. Alright, this is it. At end I will return dp of len1 len2. Len1 and len2 indexes are not present in our strings, but it will be there in our 2D dp vector because we have kept size 1 plus here. That's why we can access len1 and len2. Now let's try to run this if it is working. There is some problem. Let's see. What is the problem? j1 2 j plus plus. Okay. Okay, so the mistake is that I have to do equals here, because I have to fill this also, index length 1 and length 2, so it will run till length 1 and length 2. Now it should work fine. Yes, now let's try to submit it. Yes, it got successfully accepted. Hope you understood the problem and its approaches. If you like this video, you can consider subscribing my channel, and we'll meet in the next video. Thank you.